everyone. Today is the final day of our 6-day FDP on AI-driven robotics and vision system theory to practice. It is a matter of great privilege to introduce Professor Dr. G. FACT Chair Professor at Cochin University of Science and Technology. Professor Madhu is a highly respected academician and researcher with expertise in sustainability engineering, environmental technologies, industrial safety, and interdisciplinary research. Throughout his distinguished career, he has guided numerous doctoral scholars and contributed extensively to scientific literature through highly quality research publications. His work emphasizes sustainable development and responsible engineering practices that align with global sustainable development goals. We are fortunate to have him share his valuable insights on sustainability and the role of engineers in building a future. Please join me in welcoming Professor Dr. G. Madhu. Over to you, sir.
Thank you. Thank you very much. So thank you very much for the kind introductions. So let me thank the organizers of this faculty development program for inviting me to deliver this lecture. So I understand that this is an interdisciplinary group. We have participants from different disciplines, and also I think a few participants from outside the states have also joined. So the topic of my discussion today is sustainability and sustainable development goals. Sustainability and SDGs is the topic of my presentation. Anyway, first let me share my PPT. I'll just share this PPT. I hope this is visible to you. Is it visible?
Yes,
Yes, sir.
Yes, okay. Okay, thank you. So the concept of sustainability, it is not that new. Though it was formalized only during the 1990s, the concept was formalized only during the 1990s. The concept had its origins maybe from time immemorial. We know that civilizations used crop rotation and soil fallowing to prevent total land depletion. Mankind has been practicing this technique ever since they started agriculture. And again, during the 18th century, the term systematic forestry, it came from a German miner. His name was Hans Carl von Karlowitz. So at that time, there was a severe shortage of timber for silver mining. Timber was required for silver mining, and there was acute shortage of timber. And he published, this Hans Carl von, he published Silvicultura Oceanomica. He was a German miner. It was a publication in German language. And he coined the German term. They call it Nashkit. Anyway, we cannot pronounce it properly. The meaning is sustainable use of resources. So this visionary, he advocated for harvesting only as much as wood as the forest could naturally regrow. So it is again a concept of sustainability. But during the 20th century, there was a lot of awakening. We know that the Industrial Revolution ushered in massive pollution and also intensive resource extraction. And this trend continued unchecked till the middle of the 1900s. So maybe you might have heard of a very popular book called Silent Spring. Silent Spring was written by a professional marine biologist. Her name was Rachel Carson. She exposed the lethal impacts of synthetic pesticides on environment. Because those days, the use of different kinds of pesticides like DDT was very rampant in developed countries like the USA. So she exposed this, Dr. Rachel Carson, she exposed the lethal environmental impacts of synthetic pesticides. And this initiative, the stand taken by this Rachel Carson, shifted environmentalism from localized wildlife preservation to a holistic ecological view. But this concept was not accepted by the world nations till the 1970s. In 1972, you may be aware of this important conference. It was known as the Stockholm Conference of 1972. It was a UN conference on the human environment. This marked the very first global assembly directly linking human development with environmental degradation. Every year we celebrate June 5th as the World Environment Day. Last week, 10 days back, we celebrated the World Environment Day 2026. So the World Environment Day commemorates this important conference of 1972, Stockholm Conference of 1972. Then in the year 1981, the United Nations constituted a World Commission on Environment and Development. We know that there has been a conflict between environment and development. Earlier days, environment was considered as a separate compartment. Development was another activity. So there was no exchange of views between these two groups. So to address these issues, a World Commission on Environment and Development, it is called WECD, was constituted by the United Nations in 1981 to study the problems of development on or impact of development on environment. So this commission was chaired by the then Norwegian Prime Minister, Dr. Gro Harlem Brundtland, a very popular figure in environmental parlor. She was a medical doctor by profession, a physician. So she was appointed as assigned with the task of chairing this commission. And in the year 1987, this commission came out with a report called Our Common Future. This commission is very popularly known as the Brundtland Commission. She's a very prominent figure in Norwegian politics. She later served as the Director General of World Health Organization. She has contributed a lot to creating environmental awareness across the globe. So that is and this report first gave the formal definition of sustainability as we know today. We will come to that. So these are the contents of my presentation. First, we will discuss the basic principles of sustainability. Then we will have an overview of SDGs. then discuss about sustainable manufacturing, sustainable materials, sustainable energy, and finally about the sustainability concerns in artificial intelligence, because now artificial intelligence is influencing all fields of life. So we will discuss the sustainability concerns in AI also. So the sustainability, as I told you, so the definition given by uh, given by this Our Common Future, given in the report titled Our Common Future, brought out by the Brennan Commission, it defines, this is the popular definition that we know: meeting present needs without compromising the ability of future generations to meet their needs. That is the definition usually given by given by given in literature. So, as I mentioned earlier, it was coined fundamentally by this Brennan Commission in 1987. And this concept assumes that Earth's natural resources are limited, they are finite, and must be managed conservatively to maintain a dynamic equilibrium between human development and the planetary life support system. So there has to be a dynamic equilibrium between development and the planetary, the life support systems of our mother planet. So there are, while talking about sustainability, we have to understand that there are three pillars of sustainability. And true sustainability cannot be achieved only through environmental conservation. It is impossible to attain true sustainability through environmental conservation alone, but it requires a balanced integration of three interconnected domains. Often they are referred to as triple bottom line. We have three important domains. One is environmental sustainability. Then the second one is economic sustainability. And the third one is social sustainability. So we have three elements: environmental, economic, and social. So these are the three pillars of sustainability, or the triple bottom line: economical, environmental, social, and economic. These are the three pillars. Now, coming to environmental sustainability, this pillar demands that we consume natural resources at a rate that allows them to naturally regenerate. That is the importance. It's again, this concept was first put forward by that German miner Hans Kolber. So we have to use our resources at a rate that allows them to naturally regenerate. We have resources like water, soil, energy, fuels, forest, then natural minerals. All are natural resources. So our consumption should be in such a way that at such a rate that it allows these resources to naturally regenerate. So this concept emphasizes expanding renewable energy, because fossil fuels available on Earth, they are limited. So expand renewable energy, reduce greenhouse gas emissions. Now, all of us know that it's a big threat to our planet, greenhouse gas emissions and the associated global warming and climate change. Then protecting biodiversity, that is another important aspect of environmental sustainability. So for maintaining a balanced ecosystem, we need to protect the biodiversity. different types of plants and animal species. And also, uh, we have to transition toward a waste minimizing circular economy. Now, everyone talks about circular economy, which is based on, for example, like reduce, reuse, recycle, refurbish, like that we talk about many R's. And these R's are the basic pillars of circular economy. Instead of in a linear economy, we use something and throw it away into the environment. Whereas in the circular economy, we extend the life of that particular product by adopting all these R's. Then comes social sustainability. Here, the focus area is the basic human needs, like healthcare. Healthcare, it is the right of every human being for affordable healthcare, nutrition, shelter, and education. So, social sustainability aims at ensuring that all these basic needs are universally attainable. That is the importance. And it advocates for human rights, then labor fairness, and inclusive decision-making processes to build resilient, democratic communities with an equitable quality of life. Because every human being has a right to live with dignity. So there is a lot of importance for human rights, labor fairness, inclusive decision-making, and all that. Then the third pillar is economic sustainability. This requires businesses and governments to use resources efficiently. So they have to use resources because industries make use of different types of natural resources, and it is their responsibility to remain operational and profitable over the long term. And this can be achieved only through the efficient use of the resources that they employ. So without long-term economic viability, the organizations cannot fund green innovations or social programs required to sustain their ecological goals. Now, what are the core principles of sustainability? There are 5 core principles of sustainability. One is intergenerational equity. Then comes carrying capacity and ecological integrity. The third one is the precautionary principle. Then we have the polluter pays principle and the concept of circularity and the 6 R's. So these are considered as the core principles of sustainability. Let's examine them one by one. The first one is intergenerational equity. So it is an ethical framework. So this ethical framework states that the current generation holds the earth in trust for future generations. So that is intergenerational equity. So we are here, we are occupying this earth in trust for future generations. And the present actions, the actions of the present generation, the current generation, must not deplete natural assets, pollute vital ecosystems, or pass down climate liabilities that limit the survival capabilities of future population. So we have to take care of, because these are all realities. Because our past actions have led to the depletion of natural assets. It has resulted in pollution of vital ecosystems. And also we know that the The large-scale industrialization has led to burning of fossil fuels. It has led to climate liability. So, in intergenerational equity, we aim at reducing the impact or to do away with those activities, depletion of natural assets, pollution, and climate liabilities. The second one is carrying capacity and ecological integrity. Because we know that our planet has regenerative boundaries, because there is some limit to regeneration of the resources. So our human systems must align with this reality, must align with the regenerative boundaries of the planet. So we talk about in carrying capacity and ecological integrity, we consider two terms. One is the resource sinks and the resource sources. The resource sources are the resources they provide. The resource sources, they provide the valuable resources for human activities. And any human activity will result in the generation of, for example, some waste. So that waste should be absorbed by the ecosystem as a resource sink. So the population sizes, industrial manufacturing, and resource extraction must stay within these, within the thresholds of what ecosystem can replenish, regenerate, and what the ecosystem can absorb. For example, in terms of waste material. So it acts as a resource sink, and also at the same time, it's a resource source. That is carrying capacity and ecological integrity. Then you have the precautionary principle, taking precautions. So when an activity poses a threat of serious or irreversible harm to human health or environment, we have to adopt protective measures. Protective measures to meet this challenge, to meet the threat of serious or irreversible harm to human health or the environment. Precautionary measures must be taken. So here there is an important aspect. A lack of absolute scientific certainty should never be used as a reason to postpone cost-effective actions that prevent ecological degradation. For example, we know that the rampant use of pesticides is leading to ecological degradation. But there may not be sufficient evidence to show that these pesticides are causing the damage. But always researchers, research outputs should have come out with data regarding the environmental impacts. So a lack of absolute science. So we should not wait till the absolute scientific certainty come out. So we have to take proactive actions, precautionary steps to protect the ecosystems or the environment. Then we have the polluter pays principle. I think you are familiar with this. Whoever pollutes has to bear the cost of managing, cleaning, or remediating the impacts. That is polluter pays. See, and it's an economic rule. It dictates that the parties responsible for producing pollution must bear the financial cost of managing, cleaning, or remediating its impacts. So it's a very important principle. It is applied worldwide. And now the judicial systems all over the world, they also emphasize this principle, because large business houses, they may pollute the environment. And in earlier days, they used to shy away from their responsibility. Now it's not, it's very difficult. Usually the legal system is also now more robust, and they give a lot of importance to environmental protection. So this principle is, it has a lot of significance, and this internalizes environmental goals into business production models. In earlier days, it was not like that, because when an industry house goes for production, they have to ensure that their manufacturing processes will not impact the environment. So for that purpose, they may have to invest in pollution control equipments. They may have to go for cleaner technologies. So they're all part of the environmental cost. So this principle internalizes environmental costs into business production models. And also, there are provisions for giving incentives to entrepreneurs and business houses adopting cleaner technologies. That is also a part of polluter pays principle. Then comes the principle of circularity and the 6 Rs. Earlier I mentioned about this concept. So we know that the traditional industrial design followed a wasteful linear model. Take, make, dispose. Take resources from nature, make the product, and once its useful life period is over, you dispose it into the environment. That was the traditionally, that was the practice that we followed for a very long time. It is a sort of a linear model. Take, make, and dispose. But sustainability has shifted this paradigm of late. During the last 20 years, there has been a lot of discussions about the framework to maximize resource life cycle. So this 6R framework is very useful to maximize resource life cycles. So the first R is rethink. Changing business operations to design out waste from the beginning. So you select a technology which will not generate excessive waste, which will reduce the amount of waste. That is rethink. Then refuse. Rejecting single-use items, toxic materials, and unnecessary plastic. You just refuse. For example, in our society, now there is a very vibrant campaign against the use of single-use plastics. Single-use plastics. Because the single-use plastics, has affected our environment very badly. They are just thrown out into the environment. They are choking the drainage systems. They finally end up in rivers and oceans. And when they degrade by thermal effects and all that, microplastics will be formed in the environment. And microplastics are found to be very toxic to aquatic life and humans. So rejecting, refuse. You refuse to use. We don't want that single-use plastic. Usually we say, no, when we go to a shop or a supermarket, carry your own, what we call bags, carry bags and all that. Don't ask for single-use plastic bags like that. That is refuse. Reduce. Purposefully lower energy, water, and material consumption. That is reduce. Then reuse. Reuse of the products. Extending product lifespans through repairs, hand-me-downs, or some refurbishing or creating repurposing. These are all reuse. Then repair. Fixing broken products instead of discarding them to landfills. There may be some small defects in the product, so it is always possible to fix those broken parts. So fixing broken products instead of sending them to landfills for dumping. And the sixth R is recycle, processing unavoidable waste materials into brand new raw components. Processing unavoidable waste materials into brand new raw components. That is recycle. So, but what is more preferred is reuse. Use that product as such, extend its life. In recycling, we make something else from that waste product. That is recycled. So in the waste management hierarchy, reuse is placed at a higher level than recycle. Then why sustainability matters? Why do we attach so much of importance to sustainability? So the answer is simple. Adopting the principles of sustainability is critical to preventing systematic global collapse. Unless we follow these principles, the 6 principles that we have already seen, the global systems may collapse. So, for example, mitigating climate change. Mitigating climate change, it has widespread impacts. So the mitigation will protect vulnerable wildlife habitats, prevent severe human-wildlife conflict, and stabilizes food supply chains from extreme weather anomalies. Now, we know that climate change is leading to the destruction of wildlife habitats, and also it leads to human-wildlife conflict. That is happening in our state also now. In many states, many southern states, wildlife is entering human-inhabited areas, leading to severe conflict, human-wildlife conflict. And also mitigation of climate change stabilizes food supply chains from extreme weather anomalies. So ultimately, sustainability safeguards human survival and ensures that product does not come at the cost of the planet, at the expense of the planet. Progress should not come at the expense of the very planet that keeps us alive. That is the importance of sustainability. The next one is and also adopting the principles of sorry. Then comes sustainable development goals. I am audible, no? Hello? Am I audible?
Yes, sir. Yes, sir.
Yeah. So without, I was using an earphone. Even without that, it is audible, no? Hello? It is,
Yes,
hello?
sir. Yes, sir. It is
Now I
audible.
am audible, no?
Yes, sir.
Okay. I think I have to use that earphone. Yes. Yeah. Now coming to the SDGs. Many of you are familiar with these Sustainable Development Goals, the 17 very popular SDGs. So these Sustainable Development Goals, they represent a historic, universal blueprint to end poverty, protect the planet, and ensure global peace and prosperity. That is the important significance of these Sustainable Development Goals. So they represent a historic, universal blueprint to end poverty, protect the planet, and ensure global peace and prosperity. It has been adopted by all the 193 United Nations member states in 2015 as part of the 2030 Agenda for Sustainable Development. So it began, member states started adopting the goals in 2015, and the target year is 2030 as part of an agenda for sustainable development. So this framework, this SDG framework establishes 17 interconnected goals and 169 specific targets to be met by 2030. But we are not sure whether we will be able to meet all these goals and targets, because we are already in 2026. We are almost 11 years from the zero date. But some reports have, even in our country, the Niti Ayog, they are publishing regular reports. They are publishing reports every year that bringing out the status of implementation, status of achieving these 17 goals and 169 specific targets. In some areas, our achievement is good. We have achieved almost 60 to 70% during the last 11 years, but much more needs to be done. So this, unlike the previous global initiatives, the SDGs operate on a core unyielding principle: leave no one behind. It is an inclusive what we call framework. Leave no one behind. That is very important. No one should be left behind. Otherwise, many a time a large group of people may get marginalized from the purview of all these developmental goals. So SDGs have tried to, the 17 SDGs have tried to correct that mistake. So so as we have seen, there are 17 goals. Here the first 5 goals, 1 to 5, they deal with the social well-being. Like they aim to end poverty or hunger, ensure health, education, and gender equality, all basic human needs. Then goals 6 to 10, they deal with infrastructure, economy, focuses on water, clean energy, economic growth, innovation, and reducing necessity. There's a focus on water, clean energy, economic growth, innovation, and reducing inequality. And goals 11 to 15, they deal with the environment. They target sustainable cities, responsible consumption, climate action, and protecting marine as well as land life. And the final 2 goals, they deal with the governance. It promotes peace, justice. Proper governance should lead to peace, justice, and global partnership. That is very important. So these are the 17 4 subclasses of the SDGs. So here you can see all those popular 17 goals. First one, no poverty. Like that goes: no poverty, zero hunger, SDG 2, zero hunger. Like that. Anyway, we will see them one by one. SDG 1 is all about ensuring all types of poverty, for ending all types of poverty. No poverty, end poverty in full as its forms everywhere. That is no poverty, SDG number 1. Then comes SDG zero hunger. Zero hunger, this concept is aimed at ending hunger, achieved food and security, and improved education. So that is zero hunger. Then SDG 2 is end hunger. Again, it is related to the first SDG, end poverty. So for ending poverty, eliminating hunger is very important. Achieve food security and improved nutrition and promote sustainable agriculture. So achieve this, we have to improve food security, then improve the nutrition level and also promote sustainable agriculture. Third one is SDG 3 is good health and well-being. Again, a basic need of all human beings, good health and well-being. Ensure healthy lives and promote well-being for all at all stages. Ensure healthy lives and well-being. That is SDG number 3. SDG 4 is quality education. Ensure inclusive. That's where no one should be left behind. Ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. Inclusive and equitable education, quality education, and lifelong learning opportunities for all. It may be through formal as well as non-formal ways of learning. SDG 5 has its focus on gender equality, achieving gender equality and empowering all women and girls. Now, all world nations attach lot of importance to this SDG, achieving gender equality and empowering all women and girls. SDG 6 is clean water and sanitation. Again, another basic need. Clean water and sanitation. Ensure availability and sustainable management of water and sanitation for all. Because for a healthy life and well-being, for ensure healthy life and well-being, the availability and access to clean drinking water as well as sanitation is very important. That's why it has become a part of this agenda. SDG 6. SDG 7, it's again another important area, energy, affordable and clean energy. So we have to ensure access to affordable, reliable, sustainable and modern energy for all. That is SDG 7. SDG 8, decent work and economic growth. Promote sustained, inclusive and sustainable economic growth, full and productive deployment, and decent work for all. That is SDG 8. SDG 9, industry, innovation, and infrastructure. Again, attach lot of importance to sustainability. Build a resilient infrastructure, promote inclusive and sustainable industrialization. That's again based on the principles of sustainability and foster innovation. SDG 10, reduced inequalities. Reduce inequality within and among countries. That is again a reality. Still, lot of inequality exists between within and among the countries. So there is a need to reduce this inequality, and SDG number 10 talks about that. SDG 11 is sustainable cities and communities. Make cities and human settlements inclusive, safe, resilient, and sustainable. That is SDG 11. SDG 12, responsible consumption and production. We have to ensure that it is applicable for industries and business houses. They have to ensure sustainable consumption and production patterns. SDG 30 is climate action. Again, climate change has become a reality. It's a big threat facing our planet. So there is a need to take urgent action to combat climate change and its impacts, because we mainly focus on the reduction of greenhouse gas emissions to minimize greenhouse gas emissions in our developmental activities. So take urgent action to combat climate change and its impacts. Then comes SDG 14, that is life below water. We talk about the marine resources, seas and marine resources. So conserve and sustainably use the oceans, seas, and marine resources for sustainable development. That is life below water. This is life on earth, life on land, SDG 50. Terrestrial ecosystems. Protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forests, because deforestation is a big threat to our ecosystems. Then combat desertification. We know that the human intervention has it is sped up the process of desertification. Many fertile areas are becoming deserts, and also halt and reverse land degradation, and also stop biodiversity loss. That is SDG 15 and 15. Then SDG 16 and 17, they deal with the governance. 16 is peace, justice, and strong institutions. There is a need to promote peaceful and inclusive societies for sustainable development and provide access to justice for all and build effective, accountable, and inclusive institutions at all levels. That is SDG 16. And finally, SDG 17 talks about partnerships. Partnerships for the goals. Because to achieve the goals, there is a need for joint action. The means of strengthening the means of implementation and revitalize the global partnership. So every country, developed as well as developing countries, should come forward. They should join together to have a global partnership for sustainable development. So these are the 17 important 17 sustainable frameworks. And as we have seen, they touch upon every facet of human activity. And finally, the aim is to ensure sustainability in our actions. Now, so that is all about the concepts of sustainability and the SDGs. Now we move on to certain specific areas. One is sustainable manufacturing. So this sustainable manufacturing, it refers to the creation of manufactured products through economically sound processes. Anyway, businesses have to survive, so they have to adopt economically sound processes, but at the same time minimizing negative environmental impacts and while conserving energy and natural resources. So ultimately, any manufacturing business should ensure that the environmental impacts due to their activity should be negative while conserving energy and natural resources. And it balances economic growth, ecosystem health, and social equity, which is known as the triple bottom line. In fact, these are the three pillars of sustainability: economics, ecosystem, and the social equity. So as industrial emissions and resource depletion reach critical thresholds, transitioning from traditional take, make, linear model to circular frame has become a global imperative because they reach critical thresholds, industrial. So we have to take. Yeah. So it balances all these things. So sustainable manufacture, again, it is based on those R's. To establish a truly sustainable framework, modern industrial operations must move beyond basic recycling, but implement the 6R methodology across the entire life cycle of a product. 6R methodology like redesign, reduce, reuse, remanufacture, recover, or recycle. So it is a life. So we have to adopt this 6R methodology all throughout the entire life cycle of a product. So these are the key principles of sustainable manufacturing. This we have already seen. It's again related to the principles of sustainability. So reduce. So as far as manufacturing is concerned, minimize the use of raw materials, toxic chemicals, and energy consumption, and also reduce the waste generation during the production phase. Then reuse, designing products or components that can be used multiple times for their original or alternative purposes, that is reuse. And recycle is converting end-of-life material waste into new functional materials, that is recycle. But to avoid landfill contamination. Otherwise, all the waste will go to landfill dumps. In our country, we don't have many scientifically designed municipal landfill facilities. So there is a tendency to dump everywhere, and the local bodies, they collect these waste and dump elsewhere. That's what is happening at many places. So there is an urgent need to convert end-of-life material waste into new functional materials. So recover, remanufacture, then the enabling technologies and best practices, like now key technological, so the advanced digital platforms. Now every industry makes use of advanced digital platforms, and they act as the core architecture for optimizing material and energy efficiency. For example, the key technological deployments include manufacture execution systems like platforms like Meta's automation. They provide a real-time factory floor visibility. And this data enables prompt quality corrections, minimizing energy waste and defective scrap. And also, digital twins and IoT is also playing a major role in Industry 4 and smart operations. They are found to be useful in developing platforms like Meta's automation, and the data available in a company enables prompt action. So this digital twins, connecting factory machinery via sensors, digital twins and IoT, they allow operators to isolate high energy anomalies and continuously optimize power load. So the modern advanced technologies like AI and IoT, they are also used on a large scale in modern industries. Then you have modern manufacturing processes like additive manufacturing. Additive manufacturing has been found to be very useful in reducing material wastage. It is also known as 3D printing. This process builds parts layer by layer, and it limits material usage compared to traditional subtractive machine. Then you have a green machining fluid techniques, because you know that we make use of different lubrication fluids in our industry. So there is a need to implement maximum quarterly lubrication, which will cut the volume of toxic oil or preserving economic and equipment tool life. So then we have bio-based materials. They are all eco-friendly materials. So in place of petroleum-based polymers for biodegradable resins, we can go for polylactides, which can be used for the manufacture of bio-based materials. And it mitigates lifetime environmental impacts. There are implementation challenges in sustainable manufacturing, like financial barriers, technical and skill gaps, and also regulatory and supply chain risks. So these challenges have to be taken into account while going for the adoption of sustainable manufacturing processes. Then sustainable manufacturing. In the case of sustainable manufacturing, we make use of several analytical assessment frameworks, like life cycle assessment. Life cycle assessment is a quantitative framework to find Then closed loop supply chain analysis. So it's an analytical methodology other than life cycle assessment, we have make use of these analytical methods also. Focuses on materials flowing backwards through back-end logistic channels. So these things are there. We have to take them into account. Then comes sustainable materials. When we talk about sustainable materials, we have different types of materials. For example, we usually talk about sustainable construction materials. A lot of work is being done in this area. Then sustainable materials for engineering applications and also for chemical processes. But anyway, I will not enter all this talk. So for sustainable materials. So there are several sustainable construction materials. First, we will discuss these construction materials. So we know that the built environment is one of the single most polluting sectors in the world. But it is the construction construction industry that is causing the most damage to the environment. So then there are two reasons. One reason is the embodied carbon, because during the construction process, carbon dioxide emissions are released. So these emissions created in the construction process before a building becomes operational, they account for almost 10% of all global energy related CO2 emissions. And also we know that the production of materials like concrete is extremely energy intensive, accounting for 8% of global carbon dioxide. So there is a need to address this issue. And And with the use of traditional building materials like concrete. Concrete, we know that concrete has a high embodied emission level. And so because of this reason, the construction businesses are now considering new sustainable alternatives to reduce the carbon footprint, the carbon emissions of their building projects. So let's see some of the materials which are some of the sustainable materials which are useful in reducing the carbon footprint. But these materials, we cannot use these materials on all occasions. They are useful in certain domains. For example, bamboo. Bamboo is a naturally occurring uh, plant, and it has been used in construction industry for many years, hundreds of years. It is an extremely flexible material. We know that bamboo is an extremely flexible material, and it is very easy for construction firms to source it, and it can be found in multiple continents. So in bamboo, you can use all parts of that rapidly growing plant. It is so sustainable, and we have very little to waste. And an entire bamboo stem can be used in construction, and also it is naturally biodegradable. Construction waste can be easily disposable since the material is naturally biodegradable. The waste can be disposed of easily. That's the advantage of bamboo. Then comes mass timber usage. It is referred to as massive timber or structural timber. Especially in the Western countries, they go for the use of timber in construction field. The result of this material is the result of gluing, doweling, or nailing pieces of softer wood together in order to form larger, stronger pieces. And the process results in a material with the strength ratings of wood or concrete that is significantly lighter in weight. That is the advantage of wood. So it has generated plenty of excitement for its potential implications in sustainable construction. Many examples are available in literature. Then we have cob. Cob is a material made by crushing subsoil, sand, straw, and sometimes lime. That is called cob. We have straw, subsoil, sand, straw, and sometimes lime. So this natural building material has almost zero embodied carbon, and also it is strong and durable. Even in olden times, also people were making use of this material for constructing houses. So this sustainable material has been adopted and re-engineered to a new modern mixture. So this concept is quite old, but recently this cob material has been adopted and re-engineered by researchers to make a new modern mixture with the ability to absorb and trap heat. That is another material, cob, sustainable material. Then you have recycled steel. So along with fresh natural materials, anyway, this steel usually comes from the construction and demolition industry. Demolition industry also contribute to large quantity of waste. So the natural materials with the low embodied carbon, so in an attempt to adopt such materials, construction firms are looking to recycle existing materials with steel as a prime candidate. So we know that construction is already one of the biggest consumers of steel, and it is very easy to recycle, with around 40% of all steel production involving the use of recycled material. So recycled steel can be used to build structural components from beams, bars, and columns. Then recycled plastic. There is huge potential for recycling the plastic waste. it's there. We know that plastic is water resistant, corrosion resistant, and it has very good thermal insulation qualities. So it make an ideal material for the construction of houses. But the only problem is it doesn't have the strength of steel or even wood. So that aspect has to be judiciously considered. So recycled plastic is used to build components like lumber, fencing, floor and roof tiles, bricks, etc. Then rammed earth. It is earthen buildings. Process of creating rammed earth. It is a very old technique. It has been in use for the last for thousands of years. It involves ramming together a mixture of aggregates like gravel, clay, and sand into a framework. And this framework can be molded to create walls, which once dried, will become solid. So these walls are found to be extremely durable, requiring little maintenance and can last for hundreds of years. Then recycled glass. Glass is yet another substance that can be reused or recycled in construction. Then straw. Straw, we have seen application of straw. Bales of straw are another sustainable material with potential energy saving benefits. Anyway, as I mentioned, their use is applicable only in certain areas. We cannot use straw bale for all the applications. Then we have earth blocks, often referred to as compressed earth blocks. This sustainable material is similar to cob in its composition. Earlier we talked about cob. So this earthen block is also, it's a mixture of dry subsoil, aggregate, sand, and clay. Another material is clay brick, sustainable construction material. Clay is another green material that can be easily sourced and has been used in building projects for hundreds of years. That clay brick, it is very common now. Then recycled rubber, for example, used tires and used motorcycle bikes, they often end up in landfills. And this rubber has a very unique property. It has so recycled rubber is another aspect. Then comes and there is a material called ferro. It is a green green building material, often used as a substitute for cement. It is often created from a mixture of waste steel, dustacilic. It is both stronger than concrete and extremely sustainable. And also it's carbon dioxide, it is CO2 negative. And there are many other sustainable materials outside the construction sector. They span across fashion, consumer goods, electronics and packaging. They focus on reducing reliance on fossil fuels, lowering carbon emissions, and utilizing renewable or upcycled resources. This is about sustainable textiles and fashion materials. One important sustainable material is organic carbon. It's organic cotton. It's not carbon, it's organic cotton grown without synthetic pesticides, saving water and keeping soil healthy. Then material like hemp, it's a sort of a fibrous material, minimal water and no pesticides while yielding highly durable fibers. Then lensing tensile lyocell, they are made from responsibly sourced wood pulp processed via a closed loop system that recycle about 99% of the solvents that are used. Then natural rubber products. Natural rubber is there, mycelium leather, fungi groups Fungi roots can be grown in labs to replicate the texture of traditional animal hides. So these are all some applications. Eco-friendly packaging material. Very resourceful packaging materials are there, but you cannot use it on all applications. Use it for all applications, but it is no. Okay. So then eco-friendly packaging materials are there. We have mushroom packaging, seaweed packaging, bagasse, recycled PET bottles. PET bottles, you know, this all the beverage bottles are now made of polyethylene terephthalate, which can be very easily recycled. So such eco-friendly packaging materials are now coming to the market. Uh, then bioplastics and consumer goods. Bioplastics like polylactic acid. This is a thermoplastic derived from fermentable plant starches like corn or sugarcane, used in 3D printing and disposable cutlery. Then we know that our coir, natural fibers from plants and coconut husk, they are used for highly resilient consumer products like mats and doormats, then wheat straw plastic, then electronics and technology materials. There also there is a need for sustainable materials. We have a recycled rare earth elements because these magnets and internal circuitry can be reclaimed from old electronic products to reduce hazardous mining. And also there are post-consumer recycled plastics. So they are sourced from everyday consumer waste to build the laptop casings, smartphone bodies, and all that. Even technology leaders like Fairphone, they champion this cause. Then comes sustainable energy. So we have seen sustainable manufacturing, application of sustainability concept in manufacturing. Then about we have discussed about sustainable materials. Now sustainable energy. It's the concept of sustainable energy is known to all of you. It's the foundation of modern low carbon economies, the use of renewable sources of energy. So these resources like solar, wind, geothermal, they meet our current energy needs without compromising the ability of future generations to meet this. Because these power sources, they won't reduce any carbon dioxide. So they will lead to, they are critical to mitigating climate change, reducing pollution and establishing energy independence. Because even for a country like ours, we depend heavily on fossil fuel. So in the long run, we have to reduce the dependence on fossil fuels, and that will make our energy consumption pattern more sustainable. Then these are the different sustainable energy sources: solar, wind, hydropower, geothermal, biomass, green hydrogen. You should be familiar with most of them. So solar energy is the most abundant energy source. They can be captured and converted to electricity or heat. So these are the key technologies. The most popular one is the photovoltaic system. They use semiconductor materials to convert sunlight directly into electricity. Even rooftop photovoltaic systems have now become very popular in our country. Concentrated solar power systems. But here the mirrors focus sunlight onto a reservoir, and the intense heat will convert water into steam. It will boil water and steam is generated, and a steam turbine is used to generate utility scale energy. And solar thermal systems. Then these are the advantages of solar energy: abundance, scalability, and low operating costs. But it is, we know that power generation, you can produce solar power only during daytime. It stops at night and drops significantly during cloudy weather. Then wind energy, we are harnessing atmospheric motion. It leverages the kinetic energy of moving air. And wind turbines convert this kinetic energy into mechanical power, and the generator will turn it into electricity. We know that. It's a very common technology. These are the key technologies. Onshore and offshore turbines are used, wind turbines. Advantages: high efficiency, dual land use, and rapid growth. Challenges: visual and noise impacts. That is one aspect. Some communities object to the appearance and low frequency noise of turbines. And these rotating blades, they pose a collision risk to migratory birds and bats. So it's a threat to wildlife. Then we have hydropower. Currently, the largest source of renewable electricity worldwide. Even Kerala has many hydropower projects. It relies on the natural water cycle to generate power from moving water. So the key technologies are conventional dams, barriers trap river water in a reservoir, and the release water flows through a turbine to spin a generator. Then pump storage system. Now people talk about pump storage systems. They act as a giant battery. Water is pumped to a higher reservoir when electricity demand is low, then released downward to generate power when demand peaks. That is the concept of pump storage. Then there are run-of-the-river systems. Advantages: it offers a steady, predictable, and controllable power supply, and there is very good. There is a very good potential for grid stabilization. Challenges: one is ecological disruption. That is, construction of large reservoirs can lead to ecological disruption and displacement of people, human population. Then geothermal energy. Anyway, it's not very popular in our country. Traps into the vast thermal energy stored beneath the Earth's crust. These are the key technologies: flash steam plants, binary cycle plants, and geothermal heat pumps. Advantages: continuous availability, small footprint. But there are challenges. There are location specifics, and the initial costs involved are very high. Then another option is biomass energy. That is also a sustainable source of energy. They utilize organic materials derived from plants and animals to produce electricity, heat, or transportation fuels. These are the key technologies. You can go for direct combustion. That is like burning wood or agricultural waste. You can generate steam and electricity. And combustion, now different types, different options are available. You can go for either incineration, gasification, or pyrolysis, and even pyrolytic processes are useful in the synthesis of many useful products. Anaerobic digestion. Microorganisms break down organic waste into methane-rich gas, or from our very popular biogas plants are based on anaerobic digestion. Then there is another option like biofuels, converting crops like corn, sugarcane, or algae into liquid fuels like ethanol and biodiesel. Now, our country has a very ambitious what we call ethanol blending process, ethanol blending mission, very ambitious mission. Even yesterday, the Minister for Surface Transport, Mr. Nitin Gadkari, was talking about this, mixing ethanol. How much ethanol we can mix? Now, even they are talking about internal combustion engines powered on 100% ethanol. But again, we don't know how much modifications have to be made in the engines. But anyway, there is an option. At least 20%. Now, I think now the petrol that we get is mixed with 20% of ethanol. So that proportion will go up in future. And also we have biodiesel production processes. Even the conventional petroleum refining industry is now focusing on, now they have pilot plants for making biodiesel. These are the advantages. One is waste reduction, and the other one is versatile storage. They can be stored and burned exactly when energy demand increases. But the challenges are there, emissions are there. Burning, direct combustion will release emissions, so we have to adopt very effective mitigating measures. Nowadays, we talk about carbon capture, storage and usage or utilization. CCUS, we call it, carbon capture, utilization and storage. Then food versus fuel divide. Even using agricultural land to grow fuel crops, whether it will lead to increase in global food prices. That aspect, especially in the developing countries like ours, we have to ensure that our large population, they get enough food. So how much land can we set apart for growing these fuel crops? That is again a paradox. Food versus fuel. Then finally, green hydrogen. It is rapidly emerging as a holy grail of the clean energy transition. It has been long used in industrial processes, and the traditional, so the hydrogen, the production of hydrogen is not a new process. It's not a very new process, but the fact is that the traditional methods rely heavily on fossil fuels. From fossil fuels like naphtha, natural gas, you can make hydrogen by the very popular steam reforming process. But green hydrogen is produced from water by using renewable energy. That is the speciality of green hydrogen. So it can be extracted from compounds like water or methane. And the sustainability of hydrogen depends entirely on the energy source used to isolate it. For example, in green hydrogen, it is we split water into hydrogen and oxygen. We split hydrogen and split water into hydrogen and oxygen using renewable energy. Then only it will become green hydrogen. If there is carbon dioxide generation, we have other types like gray hydrogen, blue hydrogen, and all that. So this green hydrogen production, that production process is entirely free of greenhouse gas emissions from start to finish. We have several, so renewable energy. So the requirements are, we need an electrolyzer for water splitting. Now a lot of efforts are made into develop efficient electrolyzers for splitting water and electricity, renewable electricity. And these electrolyzers are powered by renewable energy in the case of green hydrogen. These are the advantages. Decarbonizing sectors, revolutionizing heavy transport. Now these fuel cells, green hydrogen can be used in fuel cells to power heavy-duty trucks, container ships, trains, and all that. Even our country is going to have the first hydrogen fuel train in near future. These are the advantages. But challenges are there because the production costs are high and energy losses may occur at each stage, and also the infrastructure deficit. And then comes sustainability concerns in artificial intelligence. So the we know that intensive physical resources are required to train and run AI infrastructure, because the AI infrastructure is highly energy intensive. And from that angle, we have to target sustainability of AI. And at the same time, AI has lot of potential to optimize the green technologies, the renewable energy technologies, the for grid optimization. AI can play a major role. So it has a dual role. Sustainability of AI is important, and also the application of AI for achieving sustainability. So we have to consider this dual nature. So AI, these are the sustainability concerns in artificial intelligence. One is environmental footprint of AI infrastructure. Then there are socio-economic and governance concerns, and the green paradox, which I mentioned now, the AI as a sustainability solution. So environmental footprint comes from energy consumption and carbon emissions, water scarcity and thermal pollution, and upstream extraction and downstream waste. So energy consumption. So global data centers, the energy consumption of global data centers exceeded almost 380 terawatt hour in 2023, largely driven by AI operations. By 2030, the power consumption is projected to be 1000 TWh. So there is an exponential grid demand and high intensity computations. For example, a single generative AI text query consumes almost 4 to 5 times more energy than a traditional search engine. So huge amount of power is required. And also generating one AI image utilizes energy equivalent to fully charging a smartphone. Such comparisons we can make. And also carbon neutrality, that carbon discrepancies have to be looked into. Then water scarcity and thermal pollution. There is a lot of water is required. Data centers rely on millions of liters of water. So they make use of the pristine local drinking water daily to absorb server heat for cooling. Up to 80% of this water evaporates and practically removing it from the local water cycle. So water usage is also increasing. One UN estimate show that AI data centers consume 9.3 trillion liters of water annually. And this volume matches the basic domestic needs of 1.3 billion people. So there will be localized ecological strain. So upstream resource extraction, that is also there because AI graphic processing units, they rely on semiconductors for developing semiconductors, we need mining for copper and rare earth elements. Then another issue is electronic waste, generation of electronic waste, because these AI servers become obsolete within a few years, creating mountains of hazardous e-waste that pollute the landfills. Then socio-economic concerns are there, and also the green paradox. AI, as I mentioned earlier, AI has huge potential to be used as a sustainability solution. Despite its heavy footprint, AI represents a critical tool for solving climate and systematic inefficiencies when deployed responsibly. So we can use it for AI, can be used for smart grid optimization, and it can be effectively used in precision agriculture, disaster prediction, and also for accelerated innovation, because the machine learning techniques, they shortens decades long R&D life cycles down to months. Such advantages are there. So their AI plays an important role as a sustainability solution. So these are the recommendations for sustainable AI development. Prioritize green AI models, optimize algorithm architectures to prioritize computational energy efficiency, implement operational guardrails, build sustainability data lakes. These are all some recommendations. These are the recommendations for policy planners, policy makers. There is a need to enforce hard regulatory frameworks requiring tech companies to report validated, granulated water and carbon matrices. Now we have certain disclosure mechanisms, but they are not mandatory. We have to have mandate standardized disclosures. So coming to conclusion, transition to a sustainable future. It's no longer a choice. There is no choice for us, but it's an operational necessity. And by aligning the 17 Sustainable Development Goals with manufacturing, energy, and materials, industries can secure long-term resilience and profitability. And here, the SDGs provide the blueprint. Global frameworks guide corporate responsibility and measurable impact. And manufacturing must evolve because there should be more trust on circular economies. Circular economies eliminate waste and optimize resource efficiency. And there is a need for shifting energy from conventional energy to renewable energy use. Renewable power sources drastically reduce carbon footprint. And materials require reinventing. Bio-based and recycled alternatives protect finite resources. So there is a need for this transition. So this transition to a sustainable future is no longer a choice. We have to follow it for the survival of mankind. So with this, let me conclude the lecture. Thank you very much for your patient hearing. Now it's time for discussion. If you have any queries, please feel free to ask. Thank you. Any queries from the audience? So no queries? Okay. Anyway, it's a general topic. So in that case, thank you very much once again. Let me stop. Thank you.
Dear participants, if you have any doubts, please. So I hope there are no more doubts. So as we conclude this highly insightful session on sustainability and SDG, we extend our heartfelt gratitude to our esteemed resource person, Professor Dr. G. Madhu, FACT, Chair Professor at CUSAT. Sir, your thought-provoking presentation provided us with a deeper understanding of sustainable development, the significance of the United Nations Sustainable Development Goals, and the crucial role of engineers, educators, and professionals in building a more sustainable future. The knowledge, experience, and perspectives shared by you have inspired us to think responsibly about technological advancement and its impact on society and the environment. Thank you, sir, for an enlightening, inspiring, and enriching session. So, we can now officially conclude the session. For that, let me invite Mr. Jinesh KJ, Assistant Professor of Jodhi Engineering College, to deliver the word of thanks. Sir, please.
Good afternoon all. On behalf of Department of Mechatronics Engineering and Jodhi Engineering College, we sincerely thank Professor Dr. G. Madhu sir for graciously sparing his valuable time from his busy schedule to be with us today. his enlightening session on sustainability and sustainable development goal has been truly inspiring and thought-provoking. We are deeply honored by his presence and grateful for the knowledge and perseverance he has shared with us. Thank you, sir.
Thank you. Thank you very much.
Dear participant, our 12th session will be by Dr. Neetu M. and the topic is Core Approaches and Real World Applications. Thank you.